Hello there. In the last video I received a comment to calculate the center of mass of the following system, so let's do it. Here I have a uniform planet of radius capital R, and what we've done here is we've hollowed out this planet with this, inner sphere here with a radius of R over 2, right? And you can see that we've placed this little hollowed out portion asymmetrically, such that we're going from the center of our planet to the right edge of the planet. Alright, so to go ahead and calculate the center of mass of this system here, let me go ahead and start by just introducing it like an x-axis here, right? And just making the recognition that our center of mass is going to lie somewhere along this x-axis, right? Right, I'm not quite showing this in 3D here, but you can picture that this x-axis here is passing straight through the center of the planet, really, right? Such that you're capturing that you have an equal mass distribution all around the x-axis, right? Or another way of putting it, if I were to rotate that system all about the x-axis, it would look exactly the same no matter how I rotated it. And therefore, due to those rotational symmetries, we can conclude that the center of mass is going to be somewhere along this x-axis here. Does that make sense? Okay, so let's go ahead and find this location then. I'm going to go ahead and call this kind of intersection point here. This is going to be x equals 0 at the leftmost edge of my little hollow here. Okay, so the way that I'm going to tackle this problem is what we're going to do is we're going to put back in kind of the hollow here. I'm going to put this hollow back in and we're going to put together this planet, right? And when this planet is put together, it has a total mass of capital M. Okay, so that is the mass of all of the red particles plus all of the blue particles. And let me go ahead and I'm going to call this first section here section A, right? And I'm going to call this section here section B. Okay, so now we have our fully constructed planet A plus B, right? And if I were to ask you what the center of mass of this system is, you would say, oh, that's right, it's going to be right at x equals 0, right? So the center of mass of A plus B is going to be equal to 0, right? It's just at the center of this spherical planet, right? But we can also write out the center of mass of this system in terms of the centers of mass of subsystem A and subsystem B, right? We could do that conceptually by taking the mass of subsystem A times its center of mass, XA, plus the mass of subsystem B times its center of mass, XB, divided by the total mass of our system, which we're just calling capital M, right? Okay, so what we really need to collect here is we need to collect the mass of subsystems A and B, and then we also write down B's center of mass location, and then once we're there, right, we can essentially solve for the center of mass of subsystem A, right? So let's go ahead and do just that. So first off, where is the center of mass of subsystem B? Oh, that's right, B is another sphere. So its center of mass is right here at x is equal to R over 2. Great, so this guy, xb, this is going to be R over 2. Next, what are the masses of these little subsystems here? I went ahead and I said that the total mass is mass capital M, right? So let's go ahead and start by finding the mass of subsystem B here, right? So MB is going to be equal to, let's define a mass density by taking this mass capital M here, and then dividing that by the total volume of this totally spherical planet. So that's 4/3 pi times capital R cubed. And now you take your mass density, this being a uniform planet, and you multiply by the volume of subsystem B to get its mass, right? Which is going to be 4/3 pi times R over 2 cubed, right? And we're going to get a lot of canceling, cancel, 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 and cancel here. And we're going to have M over 8. Okay, so the mass of subsystem B is M over 8. So what's the mass of subsystem A? That's just going to be equal to 7M over 8, right? Because A plus B has to add up to our total mass of M. Okay, so from here, now we're just substituting everything in, right? Let's go ahead and rewrite all of this out, right? So we have that MA here is 7m over 8 times the center of mass, XA, plus m over 8 for MB times r over 2 for XB center of mass, and this is all over m, right? And this is going to equal 0, right? And so from here, we just need to solve for XA. I'm going to go ahead and cancel out my little m's. There we go. Right, let me go ahead and move this term to the other side. I'm going to have minus r over 16 is equal to 7/8 times XA, right? Or XA is equal to minus 8 over 16 times 7. R, cancel, cancel. And we have XA is equal to minus R over 14. Right, and this should intuitively make sense also that we have a minus sign here. Our center of mass started at x equals 0, and then we hollowed out a portion to the right of that. And so that ultimately pulled our center of mass a little bit over to the left. If you enjoyed this video, found it helpful, let me know in the comments and consider subscribing to the channel. I love to hear about people getting on board. But other than that, thank you so much for watching.